Welcome to the Buildings Canada webinar, Debug the Building Code, How to Make Complying with NECB Simple. Aim to educate and inspire professionals within construction, architecture, and engineering. Today's speaker is Carl Storms, Senior Applications Expert of Imaginet Technologies. Without further delay, I turn it over to the speaker himself.
Hello everyone, and welcome to Debugging the Building Code. There we go, my apologies for that. Now that we've got everything moving smoothly, let's take a quick look at the agenda for today's presentation. We're going to do a quick introduction, some current workflows that we have in the industry, benefits of using BIM when we're going to debug our code as well as our energy code, a quick look at some energy analysis functionality that we can do inside of Revit as well as BIM, some strategies, some quick examples of what we can do, some next steps, and then we'll take your questions. As we can see on the screen, it's always a little bit awkward talking about yourself, but here's what I do for Imaginet. I've been in the AEC industry for just about 20 years now. I've worked in the architectural and general contractor realm as a BIM coordinator. I've also spent some time instructing at local community colleges, and I've been with Imaginet for about 5 years now. Working with Imaginet, I do all sorts of things AEC, whether it's teaching and instructing Revit or going through and doing presentations like this one here. So what we're going to look at today inside of our presentation is we're going to take a look at these learning objectives. So we're going to see what we can do with a BIM workflow as opposed to working with a CAD workflow. We're going to take a look at how BIM may apply to working with these codes in place. And then we're also going to take a look at what we can do with compliance by using a model as opposed to flat deliverables to take a look at what we're doing. And at the end, we'll just overlook at some next steps towards our transaction. So some of the current workflows that we see today working with plans of any sort. So we know that architects and designers and engineers, we've been using 2D plans or blueprints, if you will, for some 300 plus years to try to make sure that we have all the information that we want. And generally, whether we're talking about owners or architects or even the contractors, there's somebody that has to be compliant with the building code or the energy code or whatever code it is that we're dealing with at that particular time. And this requires that these all be met before we start the construction process. As the AEC process advances and we slowly make the move from CAD to a BIM mentality, we're changing the way that we construct our deliverables. So now that we've got the ability to have these plans reviewed using a set of models, we still tend to be doing the old school workflow, which means it's very tedious. There's a lot of paper involved. It's slow, and really it costs a lot of money, not only in wages but in time, to make sure that that information gets done the way that we want it to do. So now that we've got all this new technology, there's got to be a better way. Well, of course there is. So the industry is slowly making the adoptions, and in some areas we're adopting BIM or building information modeling technology quicker than others. But as we make that move, we're starting to get these very data-rich models. We now are making these 3D BIMs, if you will, and they contain all sorts of information. And really, the sky's the limit for the information that we can put inside of that. Now, once we understand the BIM process, we've gone down that road a few times, we're really starting to save time and money during this process. And depending on where you come from on the AEC spectrum, if you're working on the architecture and engineer side, you don't necessarily get time back when you save this time in the models, but what you really do get is you get the ability to get the simple, mundane stuff out of the way and spend more time on your engineering or spend more time on your design so that you really, at the end, have a better quality product as you're working your way through. And of course, on the construction time, where they say time is money, it really holds true when we're dealing with building information modeling. As we start saving time using that process, we can find issues and correct them before we have bricks and mortar on the ground. It really does save a lot of time. Now, we take all that in place and we understand that we have the ability to improve our standard AEC workflow working with BIM, we still get back to how do we check our code. Again, whether it's building code or energy code or whatever code it is that we're looking at, the idea is that we're still going back to looking at models that we may get in a 3D platform, flattening them down and printing them off. All of that rich data that we had inside that model is no longer of any use to us because we're just looking at flat papers or PDFs. And then, of course, everything gets printed. And that's when we really decide to get high tech, when we're reviewing our plans with the good old red pencil. We pull out that to make up all of our markups and do the information that we want. So we spent all the time making our BIM, and then we dumb it down to print it out and then do all of our markups and manual work with our red pencil. So we really want to try and move away from that and having those informations in that issue inside of that project. What we want to do instead is we want to make something a little more beneficial, a little easier to work with. So a lot of times when we receive a set of drawings or we put out a set of drawings, we're going to take a look at it. We're going to do some quick review. We're going to spot any code violations, a door swinging the wrong way, there's not enough clearance, maybe we didn't have our egress paths done just exactly right. We have the ability to do that. But there's always something that's going to get missed when we have a manual process. And a case in point is this lovely exit door here. We've got some deadbolts putting in place, but we don't have the ability to have our emergency escape bar in there to get out. So of course we want to make sure that we're not in that situation. And we also have the ability to take a look at these stairs, the trademarked and famous Rem Coolhouse ramp with no handrails. Well, it gives you a bit of a funky look as you're going through and seeing that. It's also certainly not going to pass code because we have no handrails there at all when we're working on the stairs. And these are the sort of things that we try to take away when we're dealing with code, and we try to solve that. And no matter how good we are, there's always going to be these mistakes that we get in place. So while there's no cure for these code violations and things that happen, if we can take some of the simple and the mundane stuff and remove that from the human hands and put it into software or computer, then perhaps we have less of these issues. And I want to make it clear, there's certainly no mistake that we're not replacing an experienced person that goes over the plans or through the model and finds these issues, but it just leads them a little more time as they're working through. Very similar to as we were talking about earlier, dealing with BIM going from a CAD workflow into a BIM workflow. When we get that extra time back, we can just do a better job of what we're trying to get out. So the true benefit when we're working through and doing this benefit inside our building code is that we have the ability to do these automated calculations. So we have the ability to let the software do all this stuff for us, whether it's calculating a egress path, adding up some numbers in a lighting calculation, or even just warning us with a red flag if something's not quite right. Again, the power of using BIM software and having this stuff automated is the fact that it takes away that mundane and gives us the ability to move forward doing the heavy lifting, if you will. So let's take a look now at dealing with energy analysis. Now, working with energy analysis, the idea of working inside of Revit is that it gives us these powerful tools directly inside of the software. So we've input our BIM, we've got our model, and we have the ability to start doing some analysis instantaneously. And it's not only dealing with the conceptual mass, but we have all these different ways with which we have the ability to take a look at this content. And what this allows us to do is really talk about energy efficiency and do this with very little effort. So by going through this and with this process, we have the ability to lessen energy consumption in our environment. Our building owners and operators have the ability to spend less on operating the building. And what BIM allows us to do is explore how designs perform under real-world conditions on real sites. And we can do this again very early on in the process. We can also, once we've taken our model a little bit farther, we've taken it for tender, we've got that job, we can start doing design analysis on wind patterns, solar radiation, even daylighting in mind, again, much earlier before we get the bricks and mortar on the ground and everything inside the actual site. And of course, if we go to further down the road to perform building analysis, um, once we've explored these ideas at a high level at a conceptual stage or early on in the process, we can certainly hone in more on what we're trying to uh, get out of our design without having to start back at square one when we get to our building performance analysis. And just to be clear, when we're actually working with Revit, as we're doing energy analysis inside of Revit with the out-of-the-box set of tools, we have sort of three solutions that we can look at. We have conceptual analysis, which we'll take a look at a little bit later on in this presentation, where simply we can start with masses and get a real high-level understanding of how our building is going to perform. As we're going through, we're in sort of conceptual design, working our way into design development, perhaps even starting down the construction document workflow. We can get into building element analysis, which just takes the actual elements as opposed to a mass and starts doing some energy analysis in that form. And then, of course, the highest level that we can do inside of Revit is doing a room and space analysis. If we're doing it on the architectural side, it would be a room analysis. Once we move into the MEP side, where we're going to get the most information once we have our HVAC systems and all of that in place, we can run an analysis that way as well. Now, as I mentioned, when we're doing these analysis inside of Revit, we need to keep in mind that it is a design tool meant to give us information as we're working through design in that conceptual and schematic process. Again, I think once you start getting into construction documents, it's still beneficial there. It's not a full-blown tool to the same level as ETAPS or Train that you would use in there, but it does allow you to export the information and to get it out to give you some real powerful tools as we're working down the road. Now, what it does give you as you're working through the energy analysis phase is it allows you to apply assumptions. And this is why it's such an expedient task as we're working through. And a lot of these assumptions come from all of the hundreds and thousands of models that have been done before it inside of Green Building Studio, or what Autodesk is now using Insight 360. So that information is there. And some of the things that it takes into account when it's doing these assumptions are the ASHRAE 9001 energy analysis for buildings. We've got the 90.2 energy dividends for residential buildings, as well as the ventilation and acceptable indoor air quality, ASHRAE 62.1. So these are just some of the things that take into account when it's running these energy analysis. Now, as we're working through this, and these are a few images that we see on the screen of what we can actually do working inside of Revit by very quickly taking a conceptual mass and putting it in place. And again, what this allows us to do is just explore the building forms in a very early on schematic design. And not only does it allow us to take a look at what our building is going to perform like, but we can very quickly put in some masses that represent all the buildings around. So we can get a true effect of those shadow studies, lighting studies, and how that's going to affect our model once it's in place. And again, it's minimal effort, and it really allows us to take that move down the road of having a more energy efficient building without spending a lot of time on the front end. Now, once we move out of what comes with Revit out of the box with the energy analysis tools that we were showing right there, we now have the ability to work with Insight 360. Now, this is a plugin that belongs to Revit. It's a free plugin as long as you have subscription or maintenance with Autodesk, that allows you to take your analysis sort of to an extra level. And again, as we see, it's a really fast analysis process. Fast is a relative term. When we're talking about fast, we really just mean because all the hard number crunching is done inside the cloud. So it may take a couple minutes. It may take up to an hour on a really large building to crunch those numbers and get you back a report. But in comparison to going through each room, inputting all that information into an Excel spreadsheet, it's certainly going to speed up your process as you're working through. Now, as we're looking at this, one of the other things that I haven't mentioned and that is really powerful when working with the Insight tool is that not only is it part of a add-in that comes with Revit, but it's also something that if you're a Format 360 Pro user, so the paid format service, you can use this massing tool that you could do on your iPad, on your phone, if you're daring, or any web browser. You can really quickly start doing your building studies, energy analysis. Then you have the ability to do these empowering energy analysis inside of Format 360. Really what this gives us the ability to do is that with the Insight 360 integration, there are many existing workflows, whether it's the energy analysis inside of Revit or the lighting analysis, that we can span and make it sort of a holistic tool that provides all of the data that we need when we're dealing with energy analysis. We do a lot of this as well by having access to the energy plus heating and cooling data, which once we've taken our model to that stage and the MEP has put in all of their HVAC systems, we have the ability to take all this stuff and really get some good information out of our buildings. So what we're really trying to see here is that as we're using these new tools, whether you're an architect, an engineer, or owner, or any stakeholder of the building, the energy and environmental performance is really going to be much better if you have the time to put into this analysis early on. And whether you're using Revit or Format, you have the ability to do that, and it takes on another level. And we'll see how this becomes sort of beneficial when we're working with the codes, and a little bit here when we start looking at our examples. So we touched on this a little bit before, but really what is the benefit of working with energy efficiency? Well, as you might think, if we're more energy efficient, then we use less energy. And if we use less energy, that's all a good thing. And really, we understand why this is important because, we want to have less reliance on renewable energy. We see with all the things that are happening out there, whether it's with Tesla's new shingles that provide solar power or electric vehicles, autonomous vehicles. We're finding all these ways that we can have a more energy efficient future. And the AEC industry is always lagging a little bit behind. But by using our BIMs to analyze our models ahead of time, we can certainly find the benefit of working with this information and really get more information. And we see right there at the bottom of the screen, there's a link to a helpful short little post sort of talking about AEC and it's moving into the more efficiency ways of working with the building. Now, some of the strategies that we can look at, and some of these are going to seem pretty simple, but they all sort of help. We're dealing with the envelope. We want to see what's going on around the building. We make sure that we've got the right building for the right environment. We have the ability to take a look at our systems and our appliances and all of our HVAC that are have in place. When we have the ability to use high efficiency infrastructure, we can see the dollar for cents benefit. Does going from medium to high efficiency really make the same benefit that the dollar cost is? And we can see that by doing these analysis inside of the process. We can use energy simulation. And of course, we have the ability to monitor and verify the performance. And that last one really applies if we're going to take this beyond just something that we're going to use to model and deliver to our clients when we're creating our content. But we're thinking with the entire life cycle of a project in mind, and we're moving from just handing over some PDFs or some paper to actually handing over a model that the owner can use as part of their facilities management system and really track the performance so we can see the numbers that we got if we have in place. I saw a question pop up on the screen here. We'll take a look at the questions at the end of the session. So if I see a question pop up, I'm not ignoring you, but I will get to them at the end of the session. And one of the big things that I'd like to point out here on this slide, as you see in bright, bold red there, is the fact of using energy simulation. With the newer softwares, again, in this particular webinar, I'm speaking about Revit and Insight 360, but all of the BIM software out there now has the ability to bring in energy simulation. And again, whether it's the direct out of the box or you're using a tie-in through Grasshopper or through Dynamo, you really have the ability to improve our design by taking into account this energy analysis and this energy simulation before we start putting boots on the ground, as it may be. So some of the strategies that we want to look at as we're working our way through. So when we're working with our models, we want to think about things that we can do to improve our process when it comes to dealing with the National Energy Code or even just our general local building code, is by putting the things that we know and that we can do, the low-hanging fruit, we apply that right into our template. And as we get that process down and in place, we move things by having detailed libraries with intelligent information, and in our families. It's not only the models themselves that have the ability to have all this intelligent and rich analytic data in it, the families themselves that we use have that ability as well. You want to make sure you stick to your common codes. Now, I'm going to mention in advance that a lot of this presentation came from some of our fellow colleagues down in the US. So you're going to notice some US examples in here. But the idea behind it is the same, whether we're working with a local code, the National Building Code, or a code, the International Building Code. The idea behind how these examples can work is the same no matter how you apply it. You just need to make sure you're using your local information. And the last thing that we want to talk about in these strategies is the fact that we have the ability to automate in a simple way. So we don't want to get overcomplicated with our solutions. We want to take that low-hanging fruit and we want to make these small little changes that make our execution plan a little bit easier, to make our strategy for how we move forward with these analysis inside of our BIM simpler. So I'm going to start now with a few of the examples. And what I want to sort of point out is that the intention today is not to go through and be an introduction or a how-to in Revit. And it's certainly not to go through and do picks and clicks and explain all of the examples, but it's really more to give you an overview that this is something that can be done, that you have the ability to take your information from inside the model, spend a little time with it, put out some information inside of your templates or in the model itself, and really save some time by pulling that information out of the model rather than going through and manually putting in the information. So I'm going to start by taking a look at conceptual massing. So when we're dealing with conceptual massing inside of Revit, we have the ability to use the information that's already existing inside of the model. And at the conceptual mass stage, there's probably not a lot of information because we're early on. So that's where we have the power of being able to use the information from sources like Insight 360 to help make those assumptions for us. So what we're doing is we're looking through this and we're doing sort of our conceptual analysis. The first thing that we're going to start with is just a mass form. And once we have our mass form inside of Revit, we have the ability to take it that next step to put in the massing floors, and we can start moving it from a just simple mass and create an energy model from it. So it just looks a little bit different, but it takes some simple assumptions from the model, again, being derived from those thousands and thousands and thousands of test cases to give you some information about your particular project. Now, all that you really need in this case to get going is you need to know where your building actually exists in the real world so that when you bring in your analytic data from the weather stations, it's accurate. And you also want to know that it's sort of located in the proper direction, meaning true north instead of project north inside your elevation. And that's all that you really need to know. Once we start getting past that, we have the ability to start adding some information into it via Insight 360. And as you can see here, once we get to this point, we send our information up to the cloud. It does some churning and learning, and it comes back to us, and it shows us what we have the ability to do. And it's a user-friendly index that comes up that shows us what we're going to do with our model and the information that comes out of it. And I'm going to just very quickly swap over to Revit here and actually show you this sort of in real time. So now we're looking at Revit. We take a look at our 3D mass that we have in place. And essentially what we want to do is we want to do some quick energy analysis on it. So I go up to my Analyze tab, and we see out of the box we've got our model. So I'm just going to create an energy model. So I select that, and we see that it gives us the information about our particular energy model. Now, if we want to see the settings that we've done or where that information came from, we can select our energy settings, and we get a little dialog box that pops up that tells us the information. Now, if you've done some of this in a pre-2017 version of Revit, the dialog box may look a little bit different. The information's there, we just have to dig a little deeper for it. So we get into our options, we can scroll down, make sure that we want what type of building are we looking at and dealing with, and we see our assumptions. So again, we can choose from these assumptions to have something that's going to fit our location. Again, we don't have actual walls. There's nothing inside of our building yet. We're just doing this at a very rudimentary level. We can decide our HVAC system, the building type that we want, which is going to define how many hours, the occupancy load, how often people are going to be using it. We can also choose the typical glazing coverage, our sill height, whether or not we need shadow inside of a building. So we can put all that information inside of here just with making assumptions with what we're doing. We also have the ability to make sure that we've got our location in the right spot. So we can select the location, and you can choose directly from the map. So this particular model is existing inside of Winnipeg. So you navigate to where that is, you put your pin in place, and it shows you the information. Using daylight savings time, you can select that, and we're good to go. So then we can generate our model, but before I do that, we can also select individual elements. So we have a particular set of criteria that applies to the entire building, but if we want to change that for one particular location, we can tab through and select those individual elements, and then we can make adjustments inside of there for what we want them to do. As soon as I get selected here. So now we've got that in place. I'm just going to go ahead and generate, and it's going to give us that information. Now, as that is popping up on the screen there, I'm going to go through some magic of the internet, and I'm going to pull open a model that's already done. So we've got our model here. Now that we've got the energy generated, again, I can go through and tab through and select that face and make some changes to what we want to do with that in place. If I go and select just pulling up the energy model. You can see we get the energy model that comes up, tells us our cost per meter square per year, our location. We have the ability to navigate through the model, but we also have the ability to take a look at some of these quick little things that'll tell us information about where we are. Building orientation, when we select this, so depending on our degrees, how much difference does it make? And we can see in this particular case, it's a pretty simple building. It doesn't make a lot of difference, but we've got a slight difference if we're at 225 degrees versus what we're actually at, which is about 90 degrees in place. Likewise, if we go down, we can see our different shading. Again, we can see our different options. And as we actually select these, if they make a particular adjustment into our building, we can see that none of these are making a huge difference, but we have the ability to very quickly look at this information by going through and selecting our product. And again, very rudimentary. We're early on in the process. This is just information that we're looking at the early design stage, but you can see how it's a very powerful tool, and we can start making assumptions early on inside the process. Now, some of the other things that we can take a look at, stepping away for a minute from strictly energy analysis, looking into what we can do with the code in general. So some of the things that we're taking a look at, working with our key schedule here, and this is one of those sort of simple things that we have the ability to do inside of out-of-the-box Revit without really trying to reinvent the wheel very much. So this particular example is from the IBC. It tells us information about the function of the space and your occupancy factor load. Well, if we can put this information directly inside of our model, and we can have a scale that reads this, a schedule that reads this information, we have the ability to know what we're dealing with before we have to go back and manually do that information. So some of the things that we can do with this is we can make sure that when we're building this key factor form, that we have the most relevant information. So in this case, we've got, the occupancy, which type of occupancy, we've got our occupancy load, as well as our gross square footage in place. And again, just keeping it real simple, we're taking the information from the code, we're applying it into a key schedule inside of a model. And then once we have this key schedule created, we now have the ability to start applying this information into elements, or in this case rooms, inside of our model and start getting that information from it. So again, with a simple out-of-the-box schedule, or tools to make an out-of-the-box schedule, we have the ability to apply this information and put it inside of our model. We also have the ability, as we're doing this, to start looking at some other things. So we can very quickly pull in an occupancy legend that will tell us at a glance, by looking at different colors and areas, what we have inside of our model and what the occupancies are. And again, very quick and dirty element that allows us to do this, but we don't have to reinvent the wheel. We don't have to go back and look at several pages. We can let the software do the information for us. And again, this is going to auto-populate those values that we pulled in from our key schedule. So again, anytime that we have the ability to start doing this automation, it makes our lives a little bit easier. We don't have to go through and find this stuff. We can have it already put in place. Now, to show you what I'm speaking about there, we have a very rudimentary building. And if we go to that building and we take a look at our key schedule. So this is very similar to what we had from the slide. So now that we've got that input into our model, we have the ability to start taking a look at things. And if we go just to our regular plan, we just simply input our rooms inside of our model to have that in place. Now, if we go back to our, just going to our life safety schedule, we can start seeing that we have different room types. So classroom, corridor, stairwell, manager, office. They're given a specific classification, which is being pulled from that key schedule. And if we were to add something, so this particular office, let's say, is an airplane hangar. We know it's not going to be an airplane hangar, but it sort of stands out, and I think that's kind of funny. So we throw an airplane hangar, it's telling us the maximum square footage, it's giving us our occupancy load, it's giving us all that stuff, and it's giving us a total at the end. So now if we go and take a look at our keys, again, we have the ability to slide in whatever we want, and that square footage adjusts as we go through. If I go back to my level, we see we've got our information in here. If I go to see it as a colored filled legend, once again, we have our models and it tells us our information, and we now have our air office hangar, our office that's an aircraft hangar, available for us to do the information that we want. And again, it's a very quick and easy way to put this information inside of your model and to bring it through. Now, if I scroll down a little bit here and we decide that we want to do something a little bit different, just select. We can grab our legend and we can choose the colorings however we want, whether it wants to be a room occupancy load. We can change that information. And just as, for example, our aircraft hangar, if we needed that to be green, and we want it to be some sort of hatch involved. Sure. Say apply. Okay. And again, makes a quick adjustment. We have it up here. So again, it's just pulling that information that we put in from that simple key schedule and allows us to see that information as we're working our way through. So we took a look at the occupancy legend that we were going through, and basically what it does to give you that ability to quickly verify that the proper occupancy is in the proper location. And that's really what it is, a quick and easy tool to show you that information. If we move on, we also have the ability to do a couple of different area types as we're working inside of Revit. So we've got gross building area types, and inside that we've got two options when we're dealing it with. So we can do the gross building area or the exterior area. Those are your options, cut and dry, that's what you got. If we move down to looking at something as a rentable area type, we now have 6 different options of how we're going to set up those rentable area types. I won't go through reading them all off, they're there on the slide, but depending on what you need, you can set up those areas based on your type, and again, get that information out of your model without having to do calculations, because the model does that for you. You adjust a room, you move a wall, that information is going to automatically update for you. So again, you can just go back to the schedule, or even if you have a tag that's showing you the information, go back there and it's going to tell you directly as soon as you look at it. And again, if we just quickly go down to our rentable areas using our same building, we select our gross area. And then we add in our legend to tell us that. We go back to our second model. Again, we go into now we've got rentable area. We've got different types. We've got building with common area. We've got regular floor area that's not rented out. And then we've got a rented out office spaces inside our project. So again, it's just a very simple way of using out of the box Revit content to help having the software provide you information that you might need, whether it's with code compliance for your building code or energy analysis, knowing how much square footage or square meters you have inside of your building. Something else that we can take a look at is working with egress paths. So when we're working with egress paths, we have the ability to do a couple things. And while there's no specific right or wrong way out there, and with the emergence of visual programming tools like Dynamo, there's getting to be a lot more ways out there to do this. But a couple of the ways that we can do this with stuff that we have inside of Revit are what we see here in the screen. So one of the ones that we see quite often, and I'll start from the bottom, is using a railing family. So what this allows us to do is very quickly draw our path with a railing, and we have the ability to get an overall length. So the downsides of this is that we're going to see it in 3D. So we go to our 3D model, we're going to see our railing in place. Well, we can schedule a length, we can't tag it. And of course, if we have other railings that we need to see in other projects, if we start hiding that railing, that causes issues working through with that, because now we have to make sure that we're filtering the railing and the type of railing as opposed to railing en masse. The next one is our detail components. Because it's detail, we're only going to see it in the view that it's in, so that's a plus. Again, you can tag individual lengths, but you don't get a total length and you can't schedule it. So not so helpful. If we're using an adaptive component from a generic model, well, now we can schedule it, we can tag it, and we can also set it up with shared parameters. All pluses. The downside is that we now see this inside of our 3D model. So we don't want to go there. So we're taking a look at what we have inside of our paths, what all this information is. So we take that information and we create a model, or a model element in this case, our adaptive component, and it reads that information that we had from that schedule. So you can see from here, we've got this basically 6-piece egress path adaptive component that we can put inside of our model. That's going to tell us the distance from A to B all the way down to E that we have in place, and we have the ability to schedule it and put that information out. And so as we can see here, as we're putting our path in place, we select our locations, we put it in place with our little gizmo, and as we're doing that, it's going to tell us the length of those egress paths. Now, before we get into the lighting model, let's take a look at those egress paths. So again, if we go to our 3D model, when we've got one of sort of each example inside of the project here. So if I go back to egress path. So we've got our simple detail component. And we select each piece. We can see how long each piece is, but we don't have a total. I can select my railing, and it gives me an overall total. Or I can select one of our handy little egress path pieces, maximum allowable distance. So if I have a distance that's longer than that, it's going to give me a warning. It tells me the overall distance, how many segments are in it, each piece of the segment, what its total length is. And on top of all that, if I go down to my schedule, you'll see that it tells me the information that I need, egress path, as well as the distance inside of that. So we're starting to get a little more intelligence built inside of this by creating these simple little families. And again, it's not whether you're a Revit rocket scientist and working with adaptive components is easy for you, or whether you're new to Revit or you haven't worked with adaptive components. The idea is that the information can be done and that these simple things can be put inside of your family project or your project template, I should say, so that you have access to these and everybody knows how to do it. Now again, the downside to the adaptive component is that you can see we do have it inside of our 3D model. Now if I head back to the PowerPoint, we're going to take a look at, again, some easy ways that we can use a quick schedule that we put together inside of our BIM or our model to help with some of the energy model. In this particular example, I'm going to look at the lighting calculations from the NECB. So here's our lovely building, and for those of you that have done some work inside of Revit, you're going to recognize it as one of the nice sample models that we have the ability to use with. And what this allows us to do is simply just show you a nice rendered image of what we have working through the project. We created an energy model. We saw a little bit of that earlier when we did the conceptual massing process. We take this a little bit farther. This is our full-blown MEP version. Just an example of all the different sort of simple lighting elements that we have inside of our model. And then once we have all of that put in place, we've got our model set up. We now have the ability to put together a simple chart using the information that we need out of the model to get some quick calculations for us off the hop. And again, I'll show you this in a second when I do the demo. Everything in here is just simple information that comes out of the model directly in Revit. We created one column to do some math for us, but other than that, it's all out of the box stuff. So let's take a look at the example. So we've got our model here, and I'm just going to quickly go down to our schedule. So what we did inside of the schedule is we basically divided it up so that we see each individual room. We also get the room number, the room area, and of course the room area isn't going to change in any of them because all these lights are in the same room. This is just telling us that there's 4 of these lights inside this room. We've got the luminance for each room, and then we have the wattage. Now, the wattage for each light there's 4 lights in the room, so therefore down at the bottom we have the total, and this is the number that we're going to be looking for. So now we have the total wattage for that room. The one that we had to create was the wattage per square meter, and simply we did a little formula that now takes all of these numbers, so basically the area times the wattage gives us the wattage per square meter, and then it does a calculation at the bottom to give us that full information. And again, if I just go in and say edit, bring it to my schedule, again, all out of the box except for the wattage per square meter. Again, you could use per square footage depending on your requirements. And if I go to edit type, you'll think it's just a simple formula with our wattage versus our room area. And then we divide it by 1 meter squared to get rid of the units and give us our calculation. And if I quickly pull up an example, and again, depending on where you're joining from, you may have a different example. I went onto the City of Calgary website. They have some really great executable Excel forms you can download to help you work your way through Part 8 and really all the parts of the NECB. In this particular one, we're looking at the lighting report. And if I scroll down, the information that we're looking for is the building space type, our lighting density, our floor area, and our information of our LDP times the area divided by 1,000 to get us our kilowatts. If I go back into Revit, you can see that we have our wattage, we have our wattage per square feet, as well as our room area. So we can very quickly pull this information out of the model and start filling it in to our schedule 23.4. And the one thing that it doesn't do us is it doesn't like doing calculations on sum totals. There is a workaround that gets you through that calculation, but really what this allows you to do is you can even put in a simple formula directly inside of Excel to do this for you, but you can see how we can very quickly start getting this information from the model. We go down to our AV room, we got 8 square meters, we got the same 23.8, and we have all this information. So once this schedule is created, and again, schedules can be saved inside of your template. They can also be inserted into other Revit models. That gives you the ability to have access to this information and makes filling out forms like this just that much simpler. And sort of the last thing we'll look at, again, we're getting back to talking about regular building code. And for those of you that are regular Revit users, you'll be aware that some of these updates in the last couple years of Revit have made our life a little bit easier as far as it gets to what we're doing. And what I mean by that is they've made the ability to have our extensions inside of our stairs something that's a little more code friendly. We've always had the ability to go in and set up our stairs to have some code compliant issues. Say, for example, a typical rise height of 7 inches, a maximum run of 11 inches. We could set that information and let the software do the calculations to create the stair for us. Now we could take it that one step further and start setting up the information inside of our model. And again, I select the stairs, go into edit type, and you can see maximum riser height, depth, width. We can set up some of those really basic things inside of our project and have the information be there for us. We can also get even more specific if we need to have a specific calculation for our stairs, but we can do that as well. So that's been there for a while. If we want to get a little more in depth, again, we have the ability to select our railing, go into edit type, and here's where this new functionality comes into play with having the ability to affect our extensions. So if we wanted to go back into the floor, 18 inches, and you'll now see that we now have a stair that has the ability to give our return and extension into the floor. not earth-shattering stuff, but these are things that we haven't had in the past inside of Revit, and it's just ways to make working with code compliance and dealing with issues just that much easier. And because we're working with an intelligent BIM software like Revit, if we're creating our content in that, it just makes sense that we take that next step and start using some of that intelligence that exists inside of that model to help us with these calculations, to help us with these requirements, and to speed up the process. So this brings us to things that we can do for next steps. So really we want to start to get to know and love our friend at the National Energy Code for Canada. We're now on the 2015 edition. Make sure we know our local codes. Again, one of the little tidbits of facts that come with this slide that's not necessarily relevant for us up here in the Canadian market, but I thought was interesting is that in the US, there's over 100,000 different local, municipal, state, and federal codes that may be applied. So you certainly want to make sure that you're dealing with the specific code that's relevant to you. There's a handy little article by AEC Bytes that sort of talks about automating the code and how this isn't a new endeavor, but something that's been around for a while. That gives us the ability to take a look at what we're doing and just a quick peek at what that looks like. Some of the different softwares and the different things out there that are going to help you automate your code to make your life a little bit simpler. And at the time that this article was written, we were talking about standard building code functionality. But the same can be said if we're dealing with energy code, to have the ability to go in and take the information and start using some of that intelligent smarts that comes from a model and automate that process is going to make our life a lot easier. And another little handy thing from the Autodesk Building Knowledge, a little screen cap of how to create some of those lovely egress path objects. And again, a little screen cap that comes through that sort of explains how that went through. I'm not going to go ahead and play that, but you can see some handy information that you have access to that's out there. And of course, the biggest thing that you need to do when you start doing anything new, whether it's working with a new software or a new code, is you need training. And what I really mean by that is just having the ability to be allowed to spend some time to understanding and learning, whether it's the entire office or if you have a champion that needs to go out there and learn the thing. If you spend a little bit of time, if you're not just floundering in the mud, as it were, trying to get through it, a little bit of education goes a long way in these matters. And with that, I've reached the end of my presentation, so I'm going to stop gabbing here for a bit, and I'm going to open it up for some questions. I'm taking a look at CR, and he says, if you don't currently include a code review sheet in your project timeline, how do they include one seamlessly? There's no easy answer to that. Essentially, what you really want to do is you want to make sure that you understand the particular parts of the code that you want to deal with, and you want to create that information and you put it inside your oh, the name just escaped me. Your project template. Some people use those reviewed sheets, some people don't. What I've seen with a lot of people is at the very beginning of their project, they'll have the ability to have that as almost like a landing page inside of their project. I hope that answered your question, CR. I've got a couple more here from Bruce. How many different users can be set up within the software? Can they be given different types of access or authority? I'm assuming that you're talking about Insight 360, Bruce, and it comes with your Autodesk subscription to Revit. So if you have 5 licenses of Revit, then everyone can have access to that. Very similar in place if you have those 5 network licenses. That means you have 5 user accounts. Anybody that has given an account can log in and use it, whether it's inside of Revit or the web-based version. Another one from Bruce. If you export the forms, what format should they be in? If you're working inside of Revit, you can export directly out to CSV so that you can get it inside of Excel. That would be my recommendation. And we got one more here from Bruce. Do you have any clients that opt to use software halfway through a project? Can you best describe their greatest challenge? That's a great question, Bruce. Um, I know we've got clients that have sort of made the move at many different stages. I myself personally have worked on a couple projects where we've changed direction or pivoted, if you will, sort of midway through the process. It certainly can be challenging. One of the biggest things when you're changing your software mandate halfway through a project is training and getting people up to speed as you're moving forward. Sometimes you have the ability to, behind the scenes, have the two play nice together. But really, the biggest challenge is getting people up to speed and meeting deadlines when you're in the switch. I would never recommend making the switch halfway through a project. We all know that sometimes in real life that's not an option. We always prefer either a pilot project, and of course, very rarely do we have the ability to actually access a pilot project. But what's even better is to bring it into play on a project that you're working with that you've done before. So it's not a project that you're new in. You always create institutional projects, and all of a sudden you've got a high rise. Well, this is a good time to start working with BIM or with Inside 360. Probably best to do it on a project that you're familiar with. A couple more questions here. Pavel has a question. He says, do you know any real examples in Ontario where the OBC was implemented in Revit? And I don't. I'm sure that we do. We have lots of people in our office in Ontario that have worked with this, so I can certainly check into that. But off the top of my head, I don't know an example from Ontario for that. And the last one from Pavel, foreign architecture firms for design for new buildings, there is no questions. What about interior projects for alterations? Is it an effective way to build a whole energy model? All right, I think what you're asking there is that it seems to be a no-brainer to work with BIM when we're dealing with an entire project. But how about if we're just doing small interior retrofits? Does it make sense to do a whole energy model from there? And I guess it really depends on the scope of the project. I know a lot of people that are working with smaller ID or interior design projects. They would like to have this functionality. They don't necessarily have the time. And that's where something like Format 360, where you can very quickly do a massing study, put something in place, get an idea about some solar analysis at just a floor plate level, and then move on. It allows you to spend a little bit of time and still getting some information out of your conceptual model, but without going down the same level that you would inside of an actual full-blown Revit project. All right. I don't see any other questions. I just want to thank everyone for their time today and for coming to do the webinar. And I want to say thank you.
That is the end of the Buildings Canada webinar, Debug the Building Code, How to Make Complying with NECB Simple. If you missed any of today's webinar, it will be posted on buildingscanada.com shortly. Make sure that you bookmark buildingscanada.com as your go-to resource for accredited expert-led webinars, innovative product showcases, breaking industry news, white paper reports, upcoming events, and more.